Okay, guys, I'm going to show you a few examples of the types of problems that you're going to see on your homework today so you'll kind of know what's going on. So, I, as always, when you're watching a video, if you need to pause it because it's a little too fast or you don't have it all written down yet, please feel free to do that. So we're going to start with the even odd properties and some problems that you might see like that. So in these examples, it says find the value of the given trig function. And we have the cosine of negative pi over 4. Now, knowing what we know about angles in the unit circle, we could probably find negative pi over 4 on the unit circle. But we also know, using one of those even odd properties, that the cosine of a negative angle is the same as the cosine of that same positive angle. So I can really just equate that to the cosine of regular pi over 4. Then we can look at the unit circle. So get out your golden circles, and you'll be able to see that the x value of the ordered pair at pi over 4 is the square root of 2 over 2. Okay, that's our answer. On the next one, the tangent of negative pi over 4, again using one of those even odd properties, says that we can equate that to the opposite of the tangent of positive pi over 4. So again, we could find negative pi over 4 on the unit circle, but if we can use this, it's sometimes a little bit easier. So we have the negative tangent of pi over 4. We know that tangent is the y value divided by the x value, or in this case, negative, don't forget that part, square root of 2 over 2 over the square root of 2 over 2. But just like if I had 5 over 5 or 9 over 9 or negative 85 over negative 85, the answer would be 1. The square root of 2 over 2 divided by the square root of 2 over 2 is 1. And we have that negative still sitting there, so the answer here is negative 1. Okay? So that's how those things go. Then we're going to look at a couple of examples where we're going to talk about how we can use some of those other identities to help us find the value of trig functions. So here's the next one. Given that the sine of an angle is equal to 2/3 and cosine of that same angle is equal to the square root of 5 over 3, find the value of the other 4. We already know 2 of them, so we only have 4 more to go. Other 4 trig functions. Now, this is where we will start by using, for sure, the reciprocal identities. Since we know the sine is 2/3, we know that the cosecant is the reciprocal of 2/3, which is 3 over 2. Since we know the cosine, we know the secant is the reciprocal of cosine, which would be 3 over the square root of 5. But we have to rationalize that. So we'll multiply by square root of 5 over square root of 5, which is 3 square roots of 5 over 5. Okay. Now to find tangent and cotangent, we'll need to find one of them first, probably tangent, and then we'll be able to use the reciprocal to find tangent. So let's start with tangent. We also know that the tangent is sine divided by cosine. Well, we know sine and cosine. So I can have 2 over 3 divided by that sine divided by the cosine, which is 5. Well, actually, let's do this. Let's write it this way. Sine t over cosine t. Well, the sine is 2/3. The cosine is the square root of 5 over 3. Then we will multiply by the reciprocal. We could do some canceling. We end up with 2 over the square root of 5, which has to be rationalized, goes to multiply square root of 5 over square root of 5 to get 2 square roots of 5 over 5. Okay. So there's our tangent. Maybe write this. If I can get over there. There's our tangent. Now, in order to find the cotangent, we know that cotangent is the reciprocal of tangent. So remember that we could go all the way back to right before we rationalized, and we said that the tangent was 2 over the square root of 5. So I can actually say that the cotangent is the square root of 5 over 2, or the reciprocal there. So there's cotangent, we have tangent, we have, this is secant, okay, the reciprocal of cosine, and we have cosecant, the reciprocal of sine. Okay, so we were able to find the value of all of the trig functions just being given sine and cosine. We didn't have an ordered pair. We didn't have any of that stuff. We just have some of those identities to look at. Okay. All right, so I have one more that I want to show you guys. Again, if you need to pause so you can write that down, please do that. Trying to keep this as short as possible for you. Let's see here. Given that t is in quadrant 1 and that the sine of t is equal to 1/2, find the values of the other 5 trig functions. Okay. Now, anytime you're given only the value of one trig function, you will need to look down and use those Pythagorean identities. Okay. So in this case, because I know sine, I'm going to need to use the Pythagorean identity that has sine in it. So I'm going to be using the one that said sine squared plus cosine squared is equal to 1. Okay. Now, a little bit about this notation. When we write something like this, sine squared of t, let me come over here for a second and just kind of let you know that when I write sine squared of t, that's equivalent to saying the sine of t squared. Okay, but it's just a little bit shorter notation because we don't have to use parentheses. Let me make that a little bit better. There we go. We don't have to use the parentheses and such. And so, yeah, we just need to kind of keep that in mind. So that when we see this, sine squared of t, I know the sine of t is 1/2. I'm going to take that and square it, plus the cosine squared of t is equal to 1. Well, when I square 1/2, we get 1/4, plus cosine squared is equal to 1. We'll subtract 1/4 from both sides. So we have cosine squared, 1 minus 1/4 is 3/4. Then we'll square root both sides. So we have the cosine is equal to the square root of 3 over the square root of 4, which is 2. Okay, so we have those. We were able to use one of the trig identities to find that. And we also know that we're in quadrant 1. In quadrant 1, so normally when we take the square root of both sides, we would get 2 answers, a positive and a negative. But in quadrant 1, we know that the cosine is positive. So we'll only worry about the positive one. Now, for this particular example, it is interesting because you could find the ordered pair square root of 3 over 2, 1/2 in quadrant 1 on your circle, so we can actually see what that angle measure is. Now, using the sine and the cosine, I can, of course, go now and find the value of the other 4 trig functions, right? We had 5 total to find, but we just found cosine. Okay. we know that the cosecant is the reciprocal of sine. Sine is 1/2. The reciprocal of that is 2. We know that the secant is the reciprocal of cosine. So that's going to be 2 over the square root of 3. 2 over the square root of 3. And then we'll rationalize so that we get that the secant is 2 square roots of 3 over 3. We know that the tangent is sine over cosine, or in our case 1/2 divided by the square root of 3 over 2, or 1/2 times 2 over the square root of 3. When we rationalize that, or when we cancel, we get 1 over the square root of 3. We will then, here I'll write it down here again, rationalize that to end up with the square root of 3 over 3. So that, again, is our tangent. Ooh, this is getting difficult to write on way over there. And lastly, we need cotangent. And again, remember that cotangent is the reciprocal of tangent. If I go way back over here, before I rationalize tangent, we had 1 over the square root of 3. I can turn that over to just get the square root of 3 over 1, which is just the square root of 3. So there's cotangent, here is tangent, here's secant, and cosecant. Okay, and we got all of that by only knowing information, not the angle measure necessarily, not an ordered pair, but only knowing that the sine was equal to 1/2. So those are the types of problems that you're going to do on your assignment today. It's also linked here in Canvas. Good luck with those, and hopefully I will be back with you on Tuesday. We'll go over that ACT packet and also go over the rest of this trig stuff. All right? Have a great weekend. I will see you guys next week. Bye-bye.